Hi, this is Ms. Claywell with 11.3 part 2. So this is the last portion of our notes. So when we see something set up where we can have it like log equals a number, that's our goal. So our goal is to get it to log equals a number, and then we can change it to exponential form. So if I look at what I have here, I don't have log equals a number yet. I need to move that 2 to the other side. And now I have log base 2 of x minus 2 equals a number. So I have a setup of log equals a number. Like this is the setup I'm kind of looking for. Log equals a number. Now I can loop this and get its exponential form. So remember, we can go 2 squared equals x minus 2. In other words, 4 equals x minus 2, and I can just solve for x. So I have 6 equals x. If I double check that, if I put that in here, 6 minus 2, I'm still good to go. This would be positive. Remember, this has to be a positive. The argument or inside the log has to be positive. Same idea here. I want to get log equals a number. This can become multiplication. This plus can become multiplication. So I have log base 2, 7 times x minus 2 equals 2. I can loop this once I get this in this form. Four equals 7x minus 14 plus 14 plus 14 18 equals 7x. Divide both sides by 7. $18 divided by 7 equals x. So my goal is to get these in log equals a number, and then I can get it into exponential form. If I go back and look at the 18 over 7, if I were to plug that in here, I would still have a positive number, so I'm good to go. Same idea. I want to get log equals a number, a little bit more work over here. I'm going to move that 1 to the other side. And this becomes multiplication. Now I can loop this, and I get h to the first equals x plus 1, x minus 1. If you box or double distribute all that, sorry, my eights look weird on this tablet. Oh, I made a mistake here. This should be a negative. And one of these needs to be a negative. So if we double distribute or box, however you think of it, I get 8 equals x squared minus 1. You can get one side equal to 0 and solve for x. I said this is difference of squares, so x minus 3, x plus 3. So x can equal 3. And x can equal negative 3. If I look at this up here, the negative 3 does not work because I would have a negative 3 plus 1 wouldn't work. Negative 3 minus 3. So inside the log could not be negative. So this one works. This one. Sorry. This negative 3 does not work. So however you want to show that. But the negative 3 does not work. The positive 3 does work. Similar setup to that is what we have over here. I'm going to add 8. I get a 4. And I want to write this as 1 log. So x plus 6 times x, I can loop it. 4 squared equals x times x plus 6. 16 equals x squared plus 6x. Oh no, sorry. Guys, give me a second, something's happening. Okay, sorry, I just need to finish this last one. So I can add 8 to both sides. And I get that to be 4. And then I can loop this now. So 2 to the 4th equals x plus 6 times x. 16 equals x squared plus 6x. I can move that 16 to the other side. If I did an AC tree of this, what multiplies to negative 16, but adds to 6 would be 8, and negative 2. So I have a plus 8 and a minus 2. So my options for x is a negative 8 and a 2. If I go and check these in my original, I can't do a negative 8. It would not work. Negative 8 plus 6, I get a negative 2, so that doesn't work. So I cannot do my negative 8, but my option of 2, it does work. Okay, guys, thanks for following along. I'm happy to answer questions once I'm back. Bye!